tell me about the strength of the this is a graded potential, these numbers. Tell me about the strength of the graded potential relative to the strength of the stimulus. Strong stimulus, strong graded potential. Weak stimulus, weak graded potential. Tell me about the strength of the graded potential with distance away from where it was started. Decreases or increases? Decreases. This is less strong here, right? So we could have been really strong right here, but because we rely on diffusion to spread the graded potential through the cell body, the soma, right? It could be weak by the time it gets here. It's going to take time, right? Because this cell says, hey, sodium doesn't belong here, let's pump it out. But as long as sodium's coming in, we got this gradient, some sodium's going to be pushed this way. And at some point we're going to depolarize the hillock, right? The graded potential didn't start at the hillock, it started far away from the hillock in a dendrite. But at some point, the graded potential, if strong enough, will reach the hillock. And then if it's at minus 50, so if it is a supra-threshold stimulus, what does the hillock do? The hillock generates an action potential. And what is an action potential? Depolarizing or hyperpolarizing? Depolarizing, and to what value? Was positive 30 millivolts. So this is what happens. If this is at the hillock, we're at the hillock. We had a stimulus, and this is as high as it gets at the hillock. What happens? Nothing. It goes back to rest. But what if at the hillock it does this? Then the hillock says, hey, that's important. Let's make this thing really depolarized. Boom. And let's get an action potential. And this is what an action potential looks like. Now this is a change in membrane potential at a point along the axon over time in response to an action potential. And this is the action potential. And we'll see why it's a spike. It doesn't come up here and stay up here. It reaches it and then quickly comes back down. The significance of that, reaching it and quickly coming back down, is that as soon as I get back down here, what can I get another one? I can get another action potential. But if I stayed up here, can't get it. Use it and it's done. Okay? And the way that, you okay if I use the word postsynaptic cell? Remember, we go down the presynaptic cell, the axon releases a neurotransmitter, and the neurotransmitter is going to bind with the postsynaptic cell and cause a response. How does the postsynaptic cell know how strong the stimulus was? It doesn't know how strong the stimulus was based upon the strength of the action potential, because they're all the same, right? But it's going to know how strong the stimulus was because a strong stimulus gives you lots of action potentials. A weak stimulus, even threshold, fewer action potentials. A weak stimulus, sub-threshold, no action potentials. You with me on that? So let's think about this. So you have a stimulus. If it's very weak and sub-threshold, how many action potentials? None. No action potentials. If it's weak, but strong enough to be above threshold, so we'll call it supra-threshold, you're going to get few action potentials, right? But if it's really, really strong, supra-threshold, you're going to get lots of action potentials. Okay, you okay with that? Is that okay so far? Tell me about the amount of neurotransmitter being released. No action potentials, no neurotransmitters. A few action potentials, some neurotransmitters. A lot of action potential, lots of neurotransmitters. You okay with me on that? So that's how we encode, if you will, the strength of the stimulus, is by how many action potentials do you get. If you got depolarized to plus 30 and stayed at plus 30, you can't get another action potential. You're stuck. But as soon as I come back down here, guess what I can do again? Go back up again. And if I had a strong stimulus, that's what I'd keep doing. Keep sending action potentials one after the other. Okay, got that one.